Okay, I've got a question here that's again going to be using modelling with exponentials, but this time I've got an E. I just wanted to do an example with an E in here. So we've got antibodies that are present in the human body. We've got our model here. And the first question is the initial amount of antibodies present. Now, I explained in the previous video, initial is like a trigger word to me, and that is t equals 0. So initially t equals 0. So I'm going to put t equals 0 into here, and I'm going to get e to the power of 0. Okay, so a0 is 400 times e to the power of 0, and e to the power of 0 is 1. So it's going to be 400 here, add 50, so 450. Okay, B, find the time it takes for the antibodies to be halved. So if it starts with 450, we're looking for the t value when it drops down to half of 450, which is 425. Now it's going to be slightly different from the last one because we've got an extra calculation to do in here. T plus 50. I'm going to take away 50 from both sides, and then I'm going to divide by 400. So I'm going to end up with e to the negative 0.05 t, 225, take away 50, and then divide that by 400 is going to give me 0.4375. Now what I want to do next is take a logarithm of both sides, just like I did in the previous question, but I'm going to take a natural logarithm because of the e here. When I take the natural logarithm of 0.4375 and I take the natural logarithm of the other side, what has happened here is that natural log of e is 1, and this thing here drops out to the front. So I'm left with, if I carry on up here, I'm going to be left with negative 0.05 t equal to the log of this. Now actually I know that this is going to be a negative number because it's less than 1, and I'm going to divide by negative 0.05. So let's do that. Let's do natural log of my previous answer and then divide it by this number here. And I get 16.53. Now that means after 16 minutes it hasn't halved, but after 17 minutes it has. So I finally want to round t off to the nearest minute. I'll probably leave both calculations so they can see, the examiner can see exactly what I'm doing.